I'm Director of Research and Development at Bayard Rock. We do anti-money laundering research and development. We're owned by another company that deals with all the banks. And so we get to do lots of greenfield stuff, and it's a lot of fun, but we do solve a lot of problems that are pretty annoying in their own way. I'm going to walk you through it first, what we do. So there's a lot of kind of risk that banks are worried about. There's not only law enforcement and terrorists and drug lords, they also mandated by law to monitor people that could be doing money laundering, like ambassadors or ministers of finance and their relatives. So there's a very sort of complicated system around all of this. I'm not going to go into the details of how the banks deal with it. They have their own internal sort of processes, also based on the country they're in, for exactly the action they take. But pretty much the main goal of what I'll be talking about is finding certain people inside bank data. So we use primarily the Frege-Sunter model. There's a lot of newer techniques than this, but they don't scale nearly as well. And we're dealing with, for some banks, 200 million records versus our lists, which are well over 2 million. And so if you talk for some of these like n squared, then it's not really doable under any circumstances. The first sort of phase, you have to have some sort of heuristic blocking. Essentially what that does is use some sort of fast string search to determine who is similar in some way for further evaluation later. The most important thing here is you have really high throughput and it's fast. Then you take that and you derive some sort of probability for each of those pairs. And what you get from that, essentially, you carve up into buckets, and the banks deal with those buckets accordingly. This is the general process that almost everyone uses, except that most people don't have a scoring phase. Most of the people that do this, they just have some sort of blocking, and they think they're doing well, and then they write a lot of rules, but they don't have any, thanks Intel, any machine learning features or anything. And it's really kind of sad because they drown in all these false positives. So we help them with that. So blocking, there's a lot of techniques that we've investigated. Primarily what we use today is a suffix array-based suffix tree-based representation. Because it's memory efficient and also pretty fast, suffix arrays are also quite useful. But we're also looking into some other technologies with partners. This is some graphs from an eval that I was doing. And essentially what this partner does is they can match across languages, which is really quite nice if you want to work in other countries, but your list data is primarily in English or not even. We have quite a lot of Unicode, extended Unicode, but not like a lot of Arabic names and such, right? As you can see, in the bottom left here, the black part is how much they got, and the red part is how much they missed out of, we had a complete truth set for this. And so I knew how well each of them did across all of these languages. As you can see, Chinese and Japanese are not so hot. They're not that much of a concern. What's really impressive is how well they do on Arabic, which is quite hard. But their Chinese really, if you look at the threshold versus recall here, just drops off suddenly in a weird way, and that just is very indicative that it's there's something wrong with their algorithm. Science of working at a small company where you have to make everything and deal with all of the problems, not just play with fun algorithms. Plus the reality is kind of stark when it comes to Frege-Sunter as well. This is actually from a William Winkler paper who works at the census, and he pioneered a lot of this stuff. And you can see that there's two Gaussians, and one is a little bit bigger, and then there's one that's a little more spread out on the right. The right is made of the truths, and the left is made of the false positives from this blocking process. Now this is real data. This bottom part is real data that we have. And you can see over here that our true Gaussians are incredibly tiny, and they're hugely dominated by garbage in general. And so we work really hard to try to separate these two things. I mean, it's very beautiful in the theoretic picture, or even what they're able to achieve at the census, but they have a lot more data. A lot of the bank data is very bad, and yeah. And as the numbers grow, it gets harder. Subdivide things out more easily than us because they have so much more data. And also, they don't care as much about missing people. Like if you missed in the census, it's just like, oh, you're off by some margin of error. But if we miss, some Al-Qaeda or ISIS terrorist that has money in the US they're going to use for some sort of action, then, well, that's not going to look very good and no one will buy our software ever again. That's not very good. So like to deal with this problem, we take a number of steps. One of them is we include a risk measure along with our ranking measure. And the risk is essentially an extension to PageRank. This is from the patent. And essentially, it's just an iterative process that takes into account information flow over a graph that has websites, and it has people and their connections. So, if you're connected to Osama bin Laden, you're going to automatically be pretty risky because a lot of that risk will just flow onto you. So don't make friends with terrorists, right? Especially really nasty ones that are well known. And this works quite well, actually. This is one of our core sort of features that makes us stand out. Some companies just buy our ranked data. Most of them use our entire solution, but we do have a couple customers that just buy our rankings. So what we do, this is also data from a customer site, is we project this risk-versed probability, log probability, pretty much. We scale it so that bankers can understand it better. And then we carve that up into zones, essentially. Generally, anything that's 7 or above is considered automatically true and just passed to review. But then they have these armies of people whose jobs it are to review everything else. Now, normally they'd have to review all that green stuff too, because they don't actually use any kind of probability measure at most of these banks. But when they use our software, they only have to look at those yellows, which is a tiny, tiny fraction. Actually, this is a problem for us in some ways, because people don't want us to come in and destroy the size of their teams at these banks because they're important when they have a lot of people under them. So yeah, that's one of the, usually it's only when our best customer acquisition is when they're under threat by the government, because then they are like panicking to deal with this giant pile of the green stuff over there, and we come in and we're like, no problem. We can handle that. Example. We have a database that's nicely viewable through all of this. This person is not a nice guy. He's part of a Mexican drug cartel, or connected to it. He's part of the Hells Angels. Quite an exciting guy, right? Yeah, and, definitely a very risky person. We have lots of citations to indicate that he's risky from the Federal Bureau of Prisons, the Department of Justice, the New York Post even, and we have full text for all these articles for information extraction as well. These are some people that this person is connected to. I don't really know these guys well, and gals, but as you can see from their EI scores, they're quite risky, and if you clicked on them, you would see like their connections and who they are also connected to. Most of those, I'm sure, are like Hells Angels, especially in Canada, and Mexican drug cartel people in Mexico and such. With all this information and some additional digging, we sometimes put together pictures like this just to entertain our banker friends. Essentially, this is like the flow of drugs and money this person was facilitating, utilizing different crime families and cartels in different parts of the world. In Canada, they would use the Hells Angels. In the New York area, they would use the Bonanno crime family. And then they would use the Sinaloa cartel in Mexico. And essentially just this cycle of money where it would be like, oh, cocaine to marijuana and then back down. And yeah, it was pretty amazing. The unfortunate thing, so I really like this part of my job, it feels good to find bad guys, and we were like really careful about ethics. We don't find people that are like, oh man, you were late on your taxes one time, I'm sorry. Yeah, it's not like that. These are all like legitimately bad folks with lots of citations. But we end up spending a lot of time on the munging of data. I don't know if like most of you guys or gals do like data science stuff, but I found that to be like the biggest time sink, like just converting stuff to the right format, making it fit in memory, all those problems. And also there's the very subtlety of the work itself. Like you're using tools, you have to configure them properly, and you make one mistake, and then a week later you realize it, and that's a week of wasted effort, right? It's very difficult. Myself, you miss some fields that are really important, or you get like improperly parsed data and shoved into SQL fields. Even like the wrong versions, like if you're comparing two blocking engines and you're using one data set from last year and one from this year, even if it is the same underlying data set, it's going to skew the results badly. And the bad configuration of dependencies is always problematic because we have to work with all of these different bank blocking engines, essentially the things they already use to find bad guys, kind of, with an army of humans reviewing. So configuring those properly, or convincing the banks to configure them properly, can be incredibly difficult. So I've become very paranoid, double checking things, making sure that everything is correct before I put ounce of time in, because I've already lost months of my life to various problems. There's no good functional programming language solution to that. I mean, what I really want is something like Git for data. I think that would be beautiful, but it's really, there's nothing quite like that yet. Some stabs have been taken, but. The other problem we have is every single bank customer has disgustingly bad data, but every time it's different in how it's disgustingly bad. Just recently we had these cities that were jammed in with all of the information, and for the Canadian customers, just jammed in city, and the address was null, and you're like, oh my God. Or like one of the other ones that we see often is 1/1/1979 for the date of birth, which means like we don't know the date of birth, but there actually are people born on that day. So it's like, why did you choose that, right? And also we deal with a lot of EBCDIC data from mainframes. So like this Larry O'Brien, his middle initial isn't actually O. It's he's like there's no apostrophe, so it's just a space instead. And you have to be able to resolve those kinds of subtle data problems and not miss the bad guys, which actually can be pretty difficult. On site at the bank. That's the other problem. We have two kinds of customers. For some banks, we host their data and we get to have control over it, make sure everything goes well, push things as necessary and munge it. And for other customers, we send a couple of people to the bank to work on site on whatever hardware they give us. Excuse me, that's not good. Like whatever data they give us, and sometimes we even have to put the thing into their subsystem to get results out, and we can't reconfigure it. It can be a real nightmare. So we work really hard on trying to make sure that we can address these kinds of problems on the fly as necessary. So all of this motivated something we call Safe Alert Manager. It's a lazy functional program with a GUI on top or a console on top, depending on how you want to run it. It's extensible for extract, transform, reload. It's got additional ad hoc machine learning features as necessary, and programmable data cleaning. The programmable data cleaning stuff is brand new, and I'm going to talk about that a bit because I'm excited about it. As far as the data in and out, those are just kind of I think of them as codecs because I used to work at an image processing company. And so, you can take CSV or custom files from these blocking engines or whatever else. So in general, we can break down this sort of process into 5 different components. This is just the scoring part. That's our scoring and chunking is what SAM does. The blocking engine is usually left to the bank. So we have to extract stuff from the records. And depending on what this is from, that can be completely different. Like if it's a Swift message, there might be stuff in additional fields that we need to pull out. Or if it's one of them was okay, we have multiple dates of birth per customer, and they're delimited by semicolon. And you can't just put a patch in. You have to figure out a way to clean that out on the fly, separate those out. Essentially, it's like a collect in functional programming where each thing turns into more than one. You can't just scrape out everything after the semicolon. Then we have a cleaning phase, which essentially, or structuring phase. Essentially, you take things, you tokenize them, you remove characters you don't care about, you make sure the date of birth is something valid. Sometimes we use regular expression histogramming to pick the correct date of birth. If sometimes data sets are merged when they have different date of birth formats in the same data set. Things like that. Then we featureize it, we score it, and then we slice it up into those things before as seen on the graph. But each of these phases is extensible. Slicing is only configurable. You can specify your slices. That's quite easy. But the rest of these were quite a challenge to figure out how to turn into something that is extensible. Now, features are also pretty easy. They're just generally predicates, right? It's pretty easy to write predicates. But to pull in functions from a configuration file to like change how the data is cleaned took some thought. So each customer or list record can have names, dates of birth, countries, states, and cities. In reality, the states and cities and countries can be linked together or not, depending on if we have any of the information in the bank data. But this is pretty much what it looks like. And then we have a collection of functions, kind of like with configuration, sort of like Excel, where you can pick from a drop-down list of the different functions. And we can just specify, for the customer names, we want to strip out the accents, and then we want to do a one-to-many conversion with like this nicknames file, or something like that. And it's pretty simple overall, but to use. To make it was actually pretty hard. Underneath the hood, this uses FSharp quotations, which are kind of like Lisp quotations. Essentially, it's a AST that you generate on the fly and then compile. So then as I rebuild this list structure, I inject these functions into it in order to transform the data as it's rebuilding it. Now, the benefit of this is that everything is only allocated once. It goes through all these transforms, but there's only one allocation for the entire structure. The other way I was thinking about doing it initially was with lenses. And the problem with lenses is each lens requires a new allocation of the entire subtree, like everything up to the top node. And that actually was pretty slow. And this is much faster. I'm much happier with this. Two kinds of data cleaning. There's advanced, quote unquote, which means don't touch it unless you're a programmer. And there's basic. And this is an example of a basic data cleaner where it's a map, right? And we know it's a map because it just works over strings. And so what we're pointing it at is a string array, and we know how to map over a string array. So we can say, for everything in the array, apply this to it and stick the result back in its place. That's pretty easy to do. And we parameterize it with some additional, in this case, one additional parameter, which is two-space, and that's just a character array of the things we want to turn into spaces. It's pretty simple overall, but in the user interface, it drops down, and you can only put it on the things that are the right type. And the types really help out there because we know ahead of time what the types are, and they can't apply convert to spaces or space characters to the date of births, for example, if the date of births are structured. It doesn't work on integers. It's like it would explode, right? And it's good to be able to limit what the user can do with that. I intend to release most of this work as an open source library, hopefully before the end of the year, if I can get around to it. It's all in and working and great, but of course, before you open source something, you want to pretty it up and make sure that the API is nice. And there are a couple sharp edges right now. GitHub, you can find everything I'm talking about there, unless it's not from Bayard Rock, which will be stuff at the end. So I'll get started on that. So the first sort of problem that we ran into was that, using like normal programming techniques for data science totally sucks. Like the FSharp script files kind of are okay, but like there's something really nice about that IPython notebook experience where you put things in and then you get to see graphs and results mixed with code in line. So we started in on trying to do better at FSharp Web Intellisense because in general there was nothing good. Everything was bad. And we built this sort of abstract framework for it that works with ACE or CodeMirror. And you can just integrate it into whatever project you want. And so FSharp Notebook uses this, and I will be demonstrating that first off. Let me just make this a little smaller. This room isn't that big. Is that good? Can you guys read that in the back? Yes, maybe? I see some shaking heads, yes, so I'm just going to go for it. All right, so you can do some basic stuff with this. I'm going to go through this really fast because it's not really that technically impressive in this form. It's just to kind of show off what you can do. So we can go and stick images in line. That's our brand new FSharp logo. It's very nice. The community fought over it for months and months. We can do LaTeX in line, and we can automatically display the results of sequences. Sequences are lazily evaluated, so it only shows you the first 4. It's not going to evaluate the entire thing because it could be infinite. And as you can see here, this seek.init infinite is actually infinite. We can do some nice little charts very easily with the chart combinators and tables. We can take that same data, because it's just a list of tuples, and shove it into a bunch of different things like a table or a bar graph or a line chart or whatever. This is just some function definitions. Then we can apply that, and ooh, look, it's very pretty, cosines. And we also, this didn't work last time, but I'm going to give it a try. No, it's still, I think when it's zoomed in, it doesn't work properly, but this is actually like an animated GIF down here. It's just kind of making my scroll bar go nuts. We'd like to be able to do more animated stuff inside of this, and that's one of the things that we're focusing on, but we're not quite there yet, as you can see. Language that I wrote. Essentially, the problem is on .NET, there wasn't any good options for like a user predicate language. Essentially, like you have a bunch of records and you want to filter over them or make machine learning features, ask yes or no questions about these things. And I tried all of these, but they're like so overkill, except for dynamic link, which is kind of close, but still, you cannot ask an end user analyst to know the difference between an integer and a float. That is not an acceptable option. And that's what the problem with dynamic link was, and it's also just like a beta project from Microsoft that was on a blog once and never talked about again. So not really so great. But it's actually kind of a hard problem, right? Like it needs to be simple enough that people that are not regular programmers, like bash script level programmers, can handle it. To ask these questions and express their ideas about what they want to know about the data. It needs to like not be able to touch anything. That's also really important, that it can't actually break the program, because when amateurs are fiddling around, if they can mutate things, that could be disastrous. You know, they could ruin data in memory, write it out, overwrite things and not even know it, and then it'd be my fault somehow. I just know it. And also, like, terseness is extremely important as well. So I named it Barb after my pet bird. Also, it's sharp, and yeah, C#, I guess, yeah. Anyway, so I'll show you some examples of Barb in action. Didn't mention is that we get IntelliSense with #R. So we can go. This is a brand new feature, so there we go. These are my current directory stuff. Well, Win Python, right? Like that's pretty neat. It's really useful for when you have a bunch of assemblies and you're like, which one do I want? Anyway, that's not really about this demo. So we're just going to get that assembly in and then open some namespaces. This is just a simple record type. So location has a city, which is a string, a state, which is a string, a zip, which is a string. The person can have one or more names, or 0 or more names, which is just an array. An age, which represents by an integer option, which means they may or may not have an age, and then some set of locations. And so I put me and my coworker here, and I've got a couple of aliases. I got one alias, I guess, my nickname. And my age, this is actually, I made this last year, I should update this, but I'm not going to do it right now. You know, I live in Hoboken, New Jersey, but I work in the Empire State Building, essentially, and that's where those come from. And this is similar for my coworker, Mark Schiffer, who actually invented that PageRank thing. He's quite a smart guy. So let's load that data in so we can play with it. A very simple Barb. So this part is the Barb query, just the string in here, and then this is a function from person to Boolean. And that's what we're saying. We're saying build an expression, which is a Barb query, from person to Boolean. And so we're taking the absolute value of the age minus 30 and seeing if it's greater than 5, right? Very simple thing. And it's Mark. Very surprising. I know, it's this is more impressive actually. So it's got sort of set combinators or set operators in it. This is the has intersection operator. There's a couple of neat things here actually. So this is the has intersection, and then you might notice that there's 2 dots here. That's because there's multiple locations in the structure, and we want to look at all of the states. So what this says is like, get all the states, essentially. You're mapping over with this sort of property and saying, I want a collection of the states. And we're saying, are any of those New York? I rather like this ... syntax because it really is good for reducing down those collections of things. And if you have a collections of collections of collections, you can put ... So it's, you can put as many dots as necessary to get your flat data structure. It was kind of inspired by Matlab, even though I hate Matlab. It's got a little bit going for it, I guess. Finally, we have a more complicated structure here with an and a not, and it does do short circuiting, so it won't like evaluate parts that are not necessary. And here's just a quick example with multiple dots. Like we can say we want to call to upper invariant on all of the cities, So we put a dot dot here because there's multiple cities. If you want to call a method on one thing, you just use one dot. If you want to call it on a collection of things, you use two dots. And we're just seeing if that compares to New York. And so Barb does a bunch of other little things. But this is essentially what it was designed for. And I think it does a pretty good job of it. The hardest thing in writing this language was making it so the error messages weren't terrible. And that actually took months of work. It's really surprising with programming language stuff what is hard and what isn't. Have you guys heard of Mighty? Mighty is a MIT project. So for a long time, the state of art in information extraction was GPL, which is not so good for business. But MIT recently came up with Mighty, which is a nice MIT licensed library that does really nice information extraction. It's quite good at it. And so I just wrapped it up for use in FSharp. And I'll show you that quickly. Oops, that's not what I want. So we got our mighty.net, and we're just going to, this is just a little pretty printer. We're saying we have some tokens with a certain tag and an offset for our pretty results, and we're showing them how to write those, because otherwise the results look kind of gross. Next, we need to pick a model file. There's a bunch of different models available. This is not a full wrapper for Mighty yet, because in the latest version 0.2, which was released about 2 weeks ago, I think, they added a whole bunch of sort of pairwise information model stuff. And none of that is wrapped yet. This is still just the base labeler. But it would be pretty easy to extend it that way, and we probably will. It's just a bunch of p invokes and then some classes on top of it to make it nice to use. We're just going to make a new Mighty engine with a model file and then have a nice little display because it takes a little while. Like 10 seconds or so probably to load. Oh, that was fast. Nice. Okay. So now we have a sample. The first two samples are actually the baked-in samples. And these are good to show that it actually does well enough on its own. This is a little bug in our code coloring because this triple quote means until you see a triple quote, everything is in the string. And I need to report that, actually. But in any case, we're going to just try on that sample 1, and we'll look at what the results are for the information extraction. So it did pretty well. Pegasus Airlines is an organization. Istanbul is a location. Sochi, Russia, Turkey, all locations. Transportation Ministry is also an organization. In general, the new version, it wasn't nearly as good before 0.2, and it's been really impressive to me what they've been able to achieve with this new release. Also, it was rather unstable before. That was the other big thing. Like, it would crash quite often. So here we have another included in the box example, which is still not that impressive because it is obviously tuned for to some degree. As you can see, they got pretty much everything right. I'm not going to spend too much time on that because I don't have that much time. And this is something I took from Wikipedia. And in the last version, it did a kind of terrible job. Here, it does a much better job, actually. There's only one thing that's questionable, and that's that the OS February is arguably not a location. But still, you know, you're never going to get perfect. And yeah, it's definitely a date, not a location. But if you trained it more, I'm sure you could train it to understand better these sorts of bracketed notes and such. For now, it does a pretty darn good job on its own. Highly recommended for anyone who wants to do this sort of information extraction without worrying about GPLs. By us, except for the Matlab type provider, we did make the Matlab type provider. But I'm not really going to go that much into detail with that. So let's talk about type providers because they're pretty interesting. Essentially, a type provider is a compiler plugin that goes out to the internet at compile time or to cache data, depending on how you configure it, and generates types. Now, those types can be real types, like .NET true blue types that you can interrogate with reflection and whatever else, or they can be arrays types, which can be some efficient representation after you're done interacting with them. It can be whatever you want, and essentially, it's just like doing reverse reflection. You're just emitting out the things. You're like, it has this property and blah, blah, blah. And it's pretty easy. considering how neat it is and how powerful it is. So this is just a quick example of something you might do. You can just use the OData service type provider, point it at Netflix, and then when you go Netflix dot, you see titles, and like it'll show up with the IntelliSense. I'll do a demo of this in a minute, but not with Netflix. And this is the query syntax, which essentially is very much like LINQ in C#. Pretty much the same thing. This actually gets converted into an AST, and then depending on what the service can handle, will push as much to the service as it can. So Deedle is the next demo, and this was made by other people in New York City besides myself, but I applaud them for it at Blue Mountain Capital. It's essentially one of the people who worked on Pandas actually helped out with this there, and it's a data frame library for FSharp, and we're also going to show it with some type provider action. So this is something I didn't mention before. If you want to use NuGet packages in FSharp Notebook, you just do $r and then the name of the package, and you'll get the latest one. You can actually include like the versioning information if you care and such, but it's actually super handy when you're in a notebook and you're in your constrained environment where you can't access the internet, which is where our bank data lives, and we have some custom NuGet repository, and we just want to go get these packages and not worry about it. It's just £n, right? Like, not a big deal. So what we're going to do here is we're getting FSharp data, which is where a lot of the best type providers for FSharp live, all of the data ones essentially. Deedle, which is the data frame library, and then we're going to make a new World Bank data type provider instance. Now the World Bank type provider is unique among many in that you don't have to parameterize at all because there's only one World Bank site that it can access. And thankfully I have internet access, so this will work nicely. So what this does is it goes out to the World Bank and it gets the data, essentially to represent the schema, and as necessary, it'll get more. So we've gotten all our NuGet packages, everything is loaded and looking good. We don't actually have to £r to load them because £n implies a £r, which would be like the, pull it into the REPL or whatever. So we can see from this, there we go, we can look at the top level of the World Bank, we can see countries, and we can see all these different countries here. This is not in a file on my computer, this is being pulled off the internet on the fly. Lots of information here. It's quite useful. But we just want all the countries, so we're just going to go countries. Then we're going to make a function that essentially gets the population for a given year. And we're sticking it in a series so that we can stick them all together in a data frame and make them easy to manipulate later. We're going to get the population in 2002, and the population in 2012. Anything newer than that isn't so great yet because it takes a while. And then we're going to compare that information. So essentially, this little arrow means it's like a little DSL for the data frame that says, like, this is the column name, and this is the contents, and we're just saying population for the year 2002. It's pretty simple. Now we're going to take a diff of the two, and we're going to sort and take the last 5. So we're looking at who had the most population loss over time of all the countries in the world. And we can see here, Ukraine is kind of winning, I guess. But Russia's not doing so hot either in terms of population loss. Germany is actually kind of surprising, but I guess people are moving out because the taxes are high or something. I don't know. I really have no reason to know why, but this just kind of shows how easy it is, because essentially, with that data frame, we were able to just go, oh, we want to take these diffs, which essentially is this thing right here, and we're going to just turn them into series of observations, and we're going to put that in a chart, that's a column chart, with size, and it automatically pulls the names of the fields out, so all that was not specified, it was just gotten directly from this, which is pretty handy. So just similarly, we have the most population growth. I'm sure most people can guess these countries. Oh wait, what? Oh, sorry, it popped back up. It does that sometimes in a weird way. I think that's it's only during demos. I think it's demo demons or something. But yeah, India, of course, and China, Nigeria, Indonesia, Pakistan, lots of population growth, but India is definitely winning that game. So we can take those, And we can look at a couple of different instances, like we can say, okay, this is list syntax in FSharp, and we're saying, oh, we want, this is the World Bank type provider for countries. We want India in particular, and we want Ukraine, and we want United States. The reason for these double backticks is that in FSharp, you can have identifiers with spaces and other characters that are not normally allowed in identifiers, as long as they're in double backticks. So in type providers, in order to preserve all the information, instead of turning them into underscores or other stuff, we just put them in double backticks, and then you have the actual whatever was in the database or data set without really worrying about it. Then we're just going to get the population total over time, and we're going to combine all these charts. So essentially, we're mapping over that list of countries. We're making a line chart for each one, where the number is the population, and the name is just the name of the country. And we can see here, we get IntelliSense here, so we can see, oh, we want it to be the capital city instead or something, or we just want the name, though. And then we're going to combine all those charts with a legend, population over time. We want to put it to the left so it doesn't block our view, and we're going to show it. And we can see here India is going up. The United States is going up, but leveling off. And then I probably should have put the UK for this demo. I didn't even think of that, but we can do that right now, actually. So let's just do that. We'll do that right now. It'll be really easy. So we'll just go countries, United Kingdom. Okay, we got that. It's taking a minute to settle down with the IntelliSense error, but don't worry about it. It's fine. It has to do with the fact that it has to talk to a server to communicate about all the errors and such. We'd like to actually, one of the projects that we'd like to do is actually move the FSharp compiler itself into JavaScript so that we can kind of do this stuff on the fly. Well, we can already compile FSharp to JavaScript, and FSharp is written in FSharp, so why not, right? But yeah, the UK is kind of just pretty flat, similar with Ukraine, a little bit better, doing a little bit more population growth there. I think it is actually trending positive. It's interesting, right? But you can just toss things in and out, play with data with this, and it's really easy. The combination of Deedle and type providers is extremely powerful. The only downside to it is for very, very large data sets. Like, I have a machine at work with 256 gigabytes of RAM. We just bought a new one with a terabyte of RAM. And the old one has 32 cores, and they're hyper-threaded cores. And it's got a lot of processing power, RAID 5 SSDs and whatever else. This is kind of a waste because it does do, it's not the most efficient representation. So like if we're using a lot of bank data for analysis, a lot of times I'll use this on a sample and I'll play with it to see some information, but it's not the ideal solution in that case. But it's really nice for certain kinds of data. So the last thing, I'm going to talk about ranking versus regression, which came from a paper from Google. And I think that this is a really interesting idea. I mean, at first I didn't really understand the relationship or the fact that you could use regression for ranking. And the fact that they could actually be mixed is a very interesting idea because when it comes to, well, I'll show you. It's just hard sometimes to pick because sometimes you care about the ordering, but you also care about the magnitude. And regression can do a very bad job at ranking because they might be slightly out of order a whole lot, and that would just be a much worse ranking. But like the ranking itself might be a very poor regression because it might not fit the line you like very well. Regression has its problems, of course. Everyone knows that is in this sort of domain. We're just going to ignore that because we're assuming that we know what we're doing in this case. Okay, so FSharp is an excellent language for algorithms. I am like super happy because of what we're able to do with this. I also like that we can use our Greek letters right in there. But so we're just going to do like a standard ordinary least squares regression. We just make a single step as a function. Oops, not yet. Okay, so we have some matrix of features and matrix of labels, and then some theta, which is the weights on those features in order to get those labels, which is essentially this formula right here, where that y, this beta is actually the theta. Okay, no one's in the laughing mood today. And alpha is like a learning parameter that tunes how fast you learn. What we do here is we're making an infinite sequence of thetas so that we can just pull some off. And essentially this function just has a recursive function inside that keeps calling itself with the previous theta, generating a new theta, pulling that next one out and then calling itself again. It's very simple. This is called the sequence expression, and this yield bang means it's going to return many different thetas because this function returns many different thetas. Meanwhile, we just want to yield out a single theta, so that's why they're just regular yield. It's sort of similar to that dot, dot, dot thing we were talking about before. In any case, this will just give you an infinite sequence of thetas that hopefully asymptotically approach the best possible regression. And then we just pass in, using math.net, which actually supports MKL, so it's blazingly fast linear algebra. And it's all free to download. It's very nice. We just pass in the thetas, our x and y, and then we have our dense vector, which is 0, which is the column count for the theta, which of course starts out as 0. And then we just learn it. It's quite simple. But the cool thing that I thought was, wow, you can use regression for ranking, and all you have to do is subtract things. This never occurred to me, and I like studied regressions and rankings quite a lot. And until I read this paper, I had no clue that this was actually possible. But it totally makes sense, because you're just looking at the differences in things, and it's learning how to place them near each other in the correct order, because you're penalizing on the order of the features themselves, and the weights will sort of figure it out automatically. So yeah, this is a very simple table. You know, if the names are the same, the result's 0. Addresses are not the same, but in sample 1 it is, then it's 1. Sample 2 is the other -1, and if they're both 0, you also are 0. It's quite simple. So in order to do this, we're just going to use the same ordinary least squares function, but we're just going to generate a bunch of samples first, right? It's quite simple. So we make a new system random, which is like the .NET way to make random numbers. That's not very pleasant, but it works. And then we're just going to generate random indices. And then we're going to get 2 random indices, subtract the different x's, essentially. This is linear algebra, except we're doing the rows for those particular x's. So just like vector subtraction. And then the y's, which are just scalars. And then we're yielding out those values. And this syntax is like the sequence syntax, but it's arrays. Instead, what we'll get at the end is an array. So we're just going to make 1,000 samples here. Then we're going to split them off because we want the x samples and the y samples separately. So we're just going to map over the first side, turn it into a list, and then turn that into a dense matrix of row vectors, because that's essentially what it is. And then on the y side, this comma means this will be this, and then everything down here will be this. And we're just doing it, we're mapping over the second half, essentially just like pulling off all the second things. Because it's an array, it's pretty much free. Like it'll be fast. And we're just going to shove it in a dense vector of y's. This is the paper I was talking about. The impressive thing with that, I was not able to reproduce this result with at least the data sets that I work with. I found that the combined ranking and regression did a lot worse at regression. But the idea is still cool that you can use, the rankings I actually got were not bad when I did it like in pure ranking mode. But there's something fishy about the combination of the two. I still was blown away by the idea that you can do this, essentially take the thing I was so familiar with, and I was doing a lot of investigations into ways to rank these data sets. Essentially, what I want to be able to do is rank customer data. And I want the most simple possible thing so I can explain how it works to bankers. Like I could use very sophisticated methods, but we have trouble with our PageRank stuff, explaining that to the bankers. They want to know exactly how we get our numbers, and the regulators want to know how we get our numbers, and sometimes that can be rather difficult for very complex models. So it's good to have a simple model to start with, and if that is not sufficient, keep moving. And this is pretty much the simplest ranking model you could possibly think of. Subtraction. It's extremely simple. We're just yielding out all those values, making an array, and we do the same exact thing. In that way, I got the kind of poor results. But it was still interesting. So I guess that's about all I have. Are there any questions about any subsections of this? No? I could show off a little bit more Barb. I think that would be cool. Recently to Barb, we've added a couple of new things like arrays, and you can do essentially you can do unions and intersections and has intersections. So let's see. So if you wanted to do just an intersection, which is actually commonly used because we would have something where we have a customer and a provider, which is a list record. And we want to say, like, are they both in New York City or are they both in a large city? This is like a common thing because large cities tend to be, have a lot of false positives in them, right? Because there's a lot of people in the city. Like if you're in like some small town and your name is likely to be much more unique, just in general. Not always because, you know, John Smiths and whatever, or families that make up those small towns, but it can be very different. So we could do something like if we had two names, you would pretty much do locations.city to operand variant, and we'll say like customer, just one dot. And then we want to find the intersection with that with the provider. It's actually doing the IntelliSense, and that's not a good thing because this is not Sam. But I don't actually make the FSharp Notebook thing. It's one of my coworkers. I'll have to yell at him. So you would do something like this, and if you wanted to be, it's going to go left to right. So it'll just take the union of, oh, we want the intersection of these things. And then we'd say we want the, to make sure it's New York, essentially. And that's quite simple, right? Like, you get a lot of information packed into a small space, and you would use this in the context of Safe Alert Manager. Actually, I'll show you that real quick, since we have some extra time. Oh, really? I didn't see the hand signals. I guess my timing was good. I thought it was way under. I was like,
So if people like to know more about it, they probably could just ask you directly.
oh, that's true. And I wanted to also say real quick that our FSharp user group, we have tons of videos online, and even some about Deedle and such. So if you go to our meetup page, each of our meetups, if you look in the comments, will have a link to the corresponding video, and they're all on my Vimeo account, and they're high quality, usually 1080p. So check those out if you're interested. And also FSharp.org has a whole data science section. So if you want to know about these tools and the vast majority of other tools, we have autodiff, we have a lot of the same things as Python, go to FSharp.org. Or follow me on Twitter and listen to me talk about FSharp all the time.